Hi everyone. So today we are going to discuss the topic electrochemistry. So I'll be sharing the screen and we'll be starting the session. So before starting the session, I'm giving a small introduction about electrochemistry. So what is the term electrochemistry means? Electrochemistry, right? It is a study of how the electricity is connected to the chemistry. Like how can we do the application of electricity in a chemical reaction. All right. So there are a few basic terms you have to know before starting that. So let's start with a quick fact. Okay. So we know that when we are discussing or we are thinking about electrochemistry or we are thinking about anything related to electricity, we always think about the big aluminum wires we are seeing around there, right? So earlier times, the aluminum was actually very much costlier as compared to gold. Okay, so that was not used widely for a very longer period of time. Now, since aluminum is very cheaper, since it is a very good conductor of electricity, it is used in almost every electrical lines and everything. All right. So here we are going to discuss how we can convert chemical energy to electrical energy as well as electrical energy to chemical energy. All right. So I'm going to share the screen and I'm going to discuss in very detailed manner. Okay. Hope my screen is visible. All right. So we are going to discuss the topic electrochemistry. Right? We are going to discuss the topic electrochemistry. Okay. So before starting this topic, we need to know a little bit details regarding electrochemistry. So we are discussing some new terms. Okay. We are going to discuss it one by one. So first is like we have discussed this topic in redox reaction in our 11th grade already. So first term is what to say? What is oxidation? So what is oxidation? Okay. So what is oxidation? So what is oxidation? Oxidation is either, what we can say, oxidation is either loss of electrons, or you can say increase in oxidation state. Increase in oxidation state. All right. So very simple example would be I'm having an Fe2 plus is converting to Fe3 plus 1 electron. See what is happening? Here there was 2 plus charge. Now it became 3 plus charge after losing an electron. So I have to confirm how it works. We can just check. Here there is a 3 positive charge and 1 negative charge. So in total, in the right hand side, we are having 2 positive charge. So left hand side, we are having 2 positive charge. This is one of a small shortcut for us to understand how it works. All right. Just erasing it for the convenience. All right, so we got the oxidation. What is oxidation, right? Now there is different terms. Okay, we can either say as gain of more electronegative element. That is one of the term. For example, if I'm taking Fe, I'm taking Fe over here, which is Fe metal. If I'm taking that, Fe means iron, right? Iron metal I'm taking, having zero oxidation state. If it is becoming FeCl3, all right. Now here we know that oxidation state of Fe is changing from 0 to what to say 3 plus. Definitely oxidation, right? Because Fe0 is becoming Fe3 plus 3 electrons actually, right? So we can say it is a loss of electron, and we can say oxidation number is increasing from 0 to +3. Increase in oxidation number we can say. But there is another term to discuss this, that is it is gain of electronegative element. We know that when we are looking electronegativity of iron and electronegativity of chlorine, we know that chlorine is more electronegative than iron, right? Here the gain of an electronegative element automatically make the iron electropositive. So we can say in that term as well. Okay, so hope oxidation part is clear. Now similarly, if I'm talking about another term, that is reduction, we can just relate to the same. How can we relate to the same? So reduction. So reduction over here. Okay. So the reduction over here, we can say reduction as gain of electrons. This is gain of electrons. Or we can say it as decrease in oxidation number. Decrease in oxidation number. Or we can say it as just opposite of the previous one. Okay, here it is gain of electronegative element. Here will be loss of electronegative element. Or we can say that gain of less electronegative element. Less electronegative element. So how can we explain that? So let's take an example over here. All right. So let's take an example. If I'm taking calcium and I'm reacting calcium with oxygen. So what are going to get? We are going to get calcium oxide, right? I'm just balancing it out. 2 calcium over here, 2 calcium over here. Look at the oxidation number. This was 0 over here. This became 2 plus. And this was 0 over here became minus 2. Now, from the previous definition, it's very clear that calcium is undergoing oxidation and oxygen is undergoing reduction. All right. Now, here in the oxygen, I can even say in this manner, it is actually, if I'm comparing the electronegativity of calcium and oxygen, electronegativity of calcium, which is more electronegative, oxygen is definitely more electronegative. So, oxygen is actually gaining what? Here, the oxygen is gaining a lesser electronegative element, that is calcium. Okay, so we can say it as oxygen is undergoing reduction, or I can say that oxygen is actually gaining a less electronegative element. So this is another term to explain the oxidation reduction. Now, I will explain why we are discussing all these things, because it's a very basic level or building block to understand electrochemistry. All right. The next term is ion. What is ion? Ion is a, what is a charged molecule. It's a charged atom or charged molecule. The next term would be ion. Ion. That is, or we can say it as, we are saying it as ion. It could be a atom or a molecule. It could be an atom or a molecule. It could be an atom or a molecule, right? Now, what is ion? Ion is something which is having charge, right? So, atom, an example would be Cl minus. Cl minus is an ion. It is negatively charged. It is an atom. SO4 2 minus is another ion. It is again negatively charged. It is a molecule. All right. So this is an ion. We'll discuss that in detail why we are discussing what an ion is. All right. The next term is electrolyte. Electrolyte. Now, what is an electrolyte? What is an electrolyte? Electrolyte is a solution which is containing ions. All right. It is actually an ionic conductor. All right. So it is, we can, in definition, we can say that a solution contain ions. All right. A solution contain ions. All right. So this is also known as an ionic conductor. What is ionic conductor? Conductor means whichever is conducting electricity. Ionic conductor, where the ions are the medium, which is actually conducting the electricity. Now, electronic conductors are different. Like if I'm talking about a metal rod, like an iron rod, and I'm talking about a solution which is having Fe2 plus ions, both cases, the conduction of electricity is happening in different manner. So one is ionic conductor, while the other one is an electronic conductor. These are two different terms. All right. So the one more term is that is an electrode. So next term is what is an electrode. Okay. Now electrodes are of two forms. We are having inert electrode. We are having inert electrode, and we are having a what to say, active electrode. Okay, inert electrode example is platinum. We'll discuss it in detail in higher what to say, in the upcoming classes. All right. So what is an electrode? So before discussing what an electrode is something which we are dipping in the solution. Okay, it's a root which could be a inert, made of an inert metal or an active metal, which is dipping in solution. So let me take a very simple example. Okay, let me take a container which has water. Okay, this container has water in it. All right. Now I am dipping an electrode over here. Imagine this is zinc. Okay, I'm putting a zinc electrode. Now, question is whether zinc over here will become Zn2 plus 2 electrons. That means whether the zinc will actually get dissolved in water. The answer is yes, but in very, very, very smaller quantity. So we are not even considering it. All right. So it is very smaller quantity. Now, why it is very smaller quantity? All right. So why it is very smaller quantities? Because see here, after, imagine if it is even happening, the Zn2 plus ions will definitely go to the solution. So the remaining electron will be actually existing on this electrode itself. So what it means is that this electron is actually having a negative charge because of this ion electrons present. Okay, electrode is negatively charged. Negatively charged. All right. Now the solution, what happens? Because Zn2 plus ions are going to the solution, right? Solution is becoming positively charged. Now, if this reaction is happening automatically means in chemical terms, we say it as spontaneously. So if this reaction is happening spontaneously, what we can represent in this way, delta G is equal to spontaneous. Spontaneously means we can represent as delta G is equal to negative. If it is happening spontaneously, so the resulting solution will be in such a manner that the electrode is having high negative charge, or I'm just putting it as negative charge. Negatively charged, and the solution is positively charged, right? Electrode is negatively charged, solution is positively charged. Now, this is again is electrical neutrality, right? So as such, a system doesn't tend to form in this manner. So that is the reason why in normal condition, it will not happen. Now, it do happens, right? Now, the condition is different. For example, I'm taking the same condition. Instead of taking water, I'm taking CuSO4 solution. And I'm dipping a zinc rod in. Now, the situation is different. Now, if I'm taking a CuSO4 solution, now what the solution has? If I'm taking a CuSO4 solution, this has Cu2 plus ions and SO4 2 minus ions. Right? Cu2 plus and SO4 2 minus ions. Now here what happens is that, okay, the zinc is getting undergoing oxidation, that is zinc is becoming Zn2 plus 2 electrons. Now this is happening. These 2 electrons we are having will be combining with the Cu2 plus over here and combining with Cu2 plus over here, and we are getting Cu. Now this both is happening simultaneously. So that means the zinc rod is not getting negatively charged and the solution is not getting completely positively charged. Because see, this imagine one extra zinc is actually going to the solution. Okay, so one zinc is going to solution becoming Zn2 plus and leaving 2 electrons over here. Now this electron is combined with a Cu2 plus over here, and we are getting so there is what to say, if there is I'm taking a simple number for you for your understanding. Okay, imagine there is 4 Cu2 plus ions and 4 SO4 2 minus ions in the solution. All right, now one of the Cu2 plus is being replaced by Zn2 plus. Only one. All right, so Overall, does the solution's neutrality change? No, because there is 4 into 2 plus, that is 8 plus charge over here, 8 minus charge over here, nothing changed. Similarly, is an extra electron buildup happening on the extra electron buildup happening on the road? No, because the 2 electrons over there is combining with the copper, right? So because of reason that is also not happening. So it is, now this is a possible reaction. No, this is a spontaneous reaction. Now why it is spontaneous reaction? Because zinc has a tendency to give electrons and become second 2 plus. That is the, now this tendency is called what to say, the electropotential, that we'll discuss in detail in the next section. All right, so hope the basic introduction of electrochemistry is clear for you. All right, so let's do something. Let's discuss in detail what is what to say, a basic electrochemical cell looks like. Okay, so electrochemical cells are of two types. We are having galvanic cell and voltaic cell. Sorry, galvanic cell or voltaic cells and electrolytic cell. Okay, two types: galvanic cell or voltaic cell, electrolytic cell. So what is the difference between these two? Okay, so I'm taking the next heading: electrochemical cells. Electrochemical cells. Okay. Electrochemical cells. Okay. Now, electrochemical cells are of two types. We are having galvanic cell or voltaic cell, electrolytic cell. Now, galvanic or voltaic cell, in very brief manner, we can say something which is converting chemical energy to electrical energy. Chemical energy to electrical energy is called a galvanic cell. Now, electrolytic cell, now this is happening in this which manner here? It is because this chemical energy is converted to electrical energy because it's a spontaneous reaction. Spontaneous reaction. You can say it as like delta G is equal to negative. Now, electrolytic cell is something where the electrical energy is converted to chemical energy. Electrical energy is converted to chemical energy. Now that means, imagine a reaction doesn't happen as such. That means it is a non-spontaneous reaction. Non-spontaneous reaction. If it is a non-spontaneous reaction, what happens is that delta G is positive. Now we are actually providing electricity to reverse the reaction. Now this is called electrolytic cell. Now galvanic cells are used for producing electricity, like the battery we are using, the watch, what to say, mercury cell, or the normal battery we are using in torch and everything. These are galvanic cells. Electrolytic cells are, we are actually providing electricity for the chemical reaction to happen. So that is not nothing which is producing electricity, but why we are using the electricity to make certain reactions happen. Okay, all right. Now let's take a typical example of a what to say, a galvanic cell. So one example of a galvanic cell is called Daniell cell. We are going to discuss about what a Daniell cell is. Okay. Going to make it a bit bigger. Okay. Now this is an example of a galvanic cell. Now this typical cell is called Daniell cell. All right. Now let's discuss what is a Daniell cell. So what you can understand is that, okay, there is two container. One has ZnSO4, one has CuSO4 solution. Two electrodes are dipped. So we know this is an electrode. This is an electrolyte. We have already discussed these terms, right? This is an electrolyte. This is electrode. And this might be a new term for you. This is called salt bridge. I'll discuss what exactly a salt bridge is. Okay. All right. So, we'll discuss one by one what is happening over here. All right. So we have seen that there is two half cell, right? One of CuSO4, one is of ZnSO4. So we have two metal rods dipped in a solution. Now we both know that both rods are called electrodes, right? Now we are having a small U-shaped tube over here in the middle that is called salt bridge. Now in one of these cells, what happens? Oxidation happens, and in another case reduction happens, right? Where is oxidation happening? You can see from the reaction itself. Right? Where the oxidation is happening? Here the oxidation is happening, right? Zn is converted to Zn2 plus 2 electron. That means it is loss of electrons or loss of electrons, right? This is oxidation. Here it is reduction. This is already written. Oxidation, reduction. All right. Now, this oxidation half is called the anode and the reduction half is called the cathode. So where the electrons are flowing? Electrons are flowing from, see, these are two spontaneous reactions. Okay, note it down. These are two spontaneous reactions. Here, what is happening is that here the zinc is going to the solution as Zn2 plus 2 electrons. Here the copper is getting reduced to become Cu from Cu2 plus from the solution to Cu. This is happening. Now, for this to happen, this copper should be, the solution copper should be actually getting some electron, right? The Cu2 plus over here should be getting 2 electrons to get become reduced and get deposited over here. While this zinc is actually going to solution, leaving 2 electrons. So this 2 electrons, we already told that these electrons will be on this electrode, right? So what is happening is that these electrons are actually moving from here to here and reaching this solution for this reduction to happen. Now here what happens, it is a incomplete circuit, right? So we have to complete the whole circuit for this whole process to happen. That is the role of salt bridge over here. It's actually completing the circuit. Clear? All right. So current is flowing externally from anode to cathode and internally from cathode to anode. Okay. So what is, anodes are usually given negative charge, cathodes are given positive charge. Now here in the Daniel cell, zinc is acting as a anode, copper is acting as a cathode. Okay. Now in this particular cell, the voltage created after this chemical reaction is 1.1 volt. That will how that is calculated, that we'll be discussing. So I'll give a small shortcut for you to memorize this because it's really important. So the shortcut is lone. L-O-A-N. So lone, this is left, oxidation, and we are having left, oxidation, anode, negative polarity. Okay. Anode, negative. Clear? So this is what is explained over here. All right. Okay. So this is all about an galvanic or voltaic cell. The next one is an electrolytic cell. So what is electrolytic cell? Now in the same cell, imagine I am actually giving an external electricity which is opposite to the already provided electrical circuit. Like that is from, we are getting the electricity from cathode to anode. Sorry, we are getting the electricity from, the electrons are moving from anode to cathode. Imagine I'm reversing it. Okay. So what happens is that, and that potential I'm providing over there is more than 1.1 volt, the electron will start flowing the opposite direction. Okay, that is called electrolytic cell. So I will show the image over here for your understanding. This is what I say, zinc, and this is copper. Now here you can see there is a difference, right? We have discussed that zinc was negative, that is anode, and copper was positive, that is cathode. Now here what happens is we are actually providing an external electrical field over here. We are providing an external circuit over here, which is having potential greater than 1.1 volt. Now what happens is that here the copper became anode and zinc became cathode. That means copper is undergoing oxidation over here and zinc is undergoing reduction over here. So the chemical reaction over there, which is supposed to be happening spontaneously, has been reversed. That is the electrolytic cell. Okay. So I hope you understood the session. We'll be discussing from here in the next class. And we'll be discussing some questions as well. All right. So thank you so much for watching the whole video. I hope you understood the session. Have a great day.